If I'm going to do this problem here that says with one method of a procedure called acceptance sampling, a sampling of items is randomly selected without replacement and the entire batch is accepted if every item in the sample is okay, what I need to do is figure out a company has just manufactured 1,392 CDs and 509 of these are defective. If 9 of these CDs are randomly selected for testing, what is the probability that the entire batch will be accepted? So we want to again find out the probability that the entire batch will be accepted. So this is the same as saying that every item in the sample is okay, or the probability that every item in the sample is okay. And if every item in the sample is okay, that means that none are defective, so no items are defective. Okay, so what do we need to figure out here? Well, 509 out of the 1,392 are defective. So now that means that 1,392 minus 509. Alright, so if you don't know what that is, get out your calculator. So we have 1,392 minus 509, and that is, let's go back and hit enter. That is 883. So we have that 883 are not defective. Okay, so what we actually want to know is the probability, and remember we want 9 of these CDs. So the probability that the first CD is not defective, because remember no items are defective means that the entire batch will be accepted. So the first CD is not defective. And the second CD is not defective. And again, the third CD is not defective, etc. all the way down to what? The 9th CD is not defective. Okay, so what do we have here? Well, this, because it is a very small sample from a large population, I'm going to treat these as independent even though it's without replacement, and I'm going to say that the probability that the first CD is not defective and the second CD is not defective and the third is not defective and so on is equal to the probability that the first is not defective times the probability that the second CD is not defective times the probability that the third CD is not defective, and so on all the way down to the probability that the 9th CD is not defective. Okay, so what is the probability that the first CD is not defective? Well, remember that 883 out of the 1,392 are not defective. So we know that the probability that the first CD is not defective is 883 out of 1,392. Now, because we're going without replacement, that means that the second time around there are only 1,391 CDs left. And if we want